Hello Kotlin enthusiasts, today we are exploring another essential data structure in Kotlin, sets. Sets provide a unique collection of elements ensuring each element is distinct. Let's delve into the syntax and various operations you can perform in sets in Kotlin. So let's take the first, so I'm just going to remove this, and the first example we are gonna create an initialize sets. Okay, so I'm just gonna create and initialize a set over here. I'm gonna say val, give a name to the set, unique number, set, it will be in type of int. Then I'm gonna say set of, and I'm gonna say 1 2 3 4 5 3 2 1. So sets in Kotlin are under-ordered collection of distinct elements. They are particularly useful when you need to ensure uniqueness in your data. Okay, suppose I want to just print this thing. I'm gonna say println original set unique number. So it will just print all the unique numbers. It will not repeat 3 2 1. 1 2 3 4 5 will be printed. It will not take 3 2 1. So in this example, we created and initialize a set of integers using set of function. Note that duplicate elements are automatically removed, ensuring uniqueness in sets. Okay, here we go. Now let's take one more example. Just remove this code. So in this example, we are gonna get the size, then contains and is empty operations and sets. So what I'm gonna do is, let's go with the function. Let's create a function itself. I'm gonna say fun set operations. I'm gonna say let's create a set over here. I'm gonna say val colors set of red comma green comma blue. Okay, what's the problem? Now once that is done, I'm gonna print it. Println. I'm gonna say set of colors. Then what I'm gonna do is I'm gonna say let's get the size of the set. So I'm gonna say color dot size. Now I'm gonna print this, so just copy this thing, paste it over here, say set sizes, copy this, paste it, done. Now check if the set contains an element or not. So I'm gonna say val contains red contains set contains red. Then again contains red question mark. And the next is checking if the set is empty or not. So I'm gonna say val is empty set colors dot is empty, println is the set empty is empty. Just copy this set operations, paste it over here so that we could execute this function. Run this. So here we showcase common set operations such as getting the size of the set, checking if the element is present, and determining if the set is empty. Here we go. The set, the set. So this is the set that we have printed. Okay, and then the size of the set, that is 3. Then okay, just copy this and paste it over here. Contains red, the value should return true, and is empty set, the value is false because the set had elements, so it's returning. It's not empty, it's false. Okay, great. So let's take one more example in which we are going to modify the set by adding and removing elements. Here we go, it's true. Okay, so what I'm going to do is I'm going to create one more function. I'm going to say fun set modification. I'm gonna create sets, so I'm gonna say val fruits. This time I'm gonna use mutable set of. Then I'm gonna say apple, banana, and orange. Then what I'm gonna do, I'm gonna print this thing, println fruits. Then I'm gonna add element. I'm gonna say fruits dot add, suppose grapes. And again I'm gonna print it. I'm gonna say set after adding. Okay, over here I'm just gonna say original set. And the next is I'm gonna remove an element from the fruit. So I'm gonna say remove. I'm gonna say banana, println set after removing. I'm gonna say fruits. Just copy this function, paste it over here. Let's see what's the output. So in this example we use a mutable set to demonstrate adding and removing elements from a set, showcasing the dynamic nature of mutable sets. Here we go. Original set was this, then after adding grapes we have this, and then after removing banana we have this set. Okay, make sure when we are adding and removing elements we need to use mutable set over here. Okay, now let's take one more example in which union, intersection, and difference example we are going to take in sets. So I'm going to say fun um, set operations. So let's make a set. So I'm gonna say let's make two sets. Set 1, I'm gonna say set of, I'm gonna say 1 2 3 4 5, and other set is set 2. I'm gonna say set of, I'm gonna say 3 4 5 6 7, suppose. Okay, why this is red? I don't know why this is red. Okay, set operations over here and set operations over both were the same function. That's the reason. Okay, so what I'm gonna say is set op. I'm gonna say the function will be set op. Now what I'm gonna do is I'm gonna do the operations of union or two sets. So I'm gonna say val u1 i1 union set is equals to set 1 dot union set 2. So what does this mean is all the elements which are basically present in this and this. All the elements that are present in this and this, we are going to show it. Okay, and no repetition will be done, of course. So suppose 1 2 3 4 5 is present and we have 6 7. Okay, so 1 2 3 4 5 6 and all the unique elements we are going to show present in both the elements. Okay, union means this. Then what I'm going to do, I'm just going to print it. I'm going to say union of sets, and then union set. Done. Okay, now we are going to do the intersection of two sets. So I'm going to say val intersection set is equals to set1 dot intersect set1 intersect set2, and same I'm gonna print it, intersection of sets. I'm gonna say intersection set. Done. SECTI1 intersection of sets. Done. Now we are gonna take the difference between two sets. Intersection is basically the common elements, that is 3 4 and 5 are basically common in both these sets, so these three will, we are gonna print it. Okay, now we are gonna see the difference between two sets. So what I'm gonna do is I'm gonna say val difference set is equals to set1 dot subtract set2, and then I'm gonna print ln difference between sets, different sets. So what does this mean? Set1 subtract set2, that whatever element set2 has, we are going to print all the elements of set1 provided the elements are not present in set2. So we are going to print just 1 and 2 because 3 4 5 are present in set2, hence only 1 and 2 will be printed. Okay, so what I'm going to do is just copy this thing and paste it over here, and let's see what's the output. Here we explore set operations such as union, intersection and difference, providing ways to combine or extract elements from two sets. Here we go. So the union is 1 2 3 4 5 6 7, that is all the elements combining both these sets, all the elements, all the unique elements. So 1 2 3 4 5 6 are the unique elements. Now the intersection means all the common elements. The common elements in both sets are 3 4 and 5, right? 3 4 and 5. And then the subtract, so the elements that are not present in set 2, okay, and the elements, first of all, the elements that are present in set 1 we are going to take, that is 1 2 3 4 5, and we are going to check if the elements that are not present in set 2, so 3 4 and 5 are present in set 2 and 3 4 are also present in set 1, hence we are going to remove this and only the unique elements of set 1 we are going to take. Now suppose I just want to change it to set 2 over here and set 1 over here, so 6 and 7 must be printed. Okay, 6 and 7 is getting printed because 6 and 7 are unique to set 2. Great. And that concludes our exploration of sets in Kotlin. Sets are a valuable tool for managing collections of distinct elements, ensuring uniqueness. Now go ahead, experiment with sets in your Kotlin projects and enjoy the benefit they bring to maintain unique data. Happy coding, meet you in the next lecture. Thank you.